December 8th, 2017. It is B-Day. Our third objective of this unit is what is the difference between homologous structures and analogous structures. Sorry, my pronunciation is not that good with certain words that get me tongue-tied, like plastic spoons. All right, I'm over it. Anyway, you're going to be doing a lab that makes you look at these three different things and analyze them. Let's go over yesterday's question before we start. Yesterday's objective question asked us, what evidence do scientists have that allowed us to believe or come up with this theory of evolution? What is the evidence? You don't just make up theories and they become true. You need facts. So, Darian, give me one fact that scientists use to help explain the theory of evolution. Good, they're using the artifacts. So what do we call those artifacts? So we can make bullets. Scientists use, you know what they are, the artifacts like bones and such. What are they? Thank you. Scientists use fossils. What other things do they use to tell the story of evolution? Besides fossils, what other things help us compare? Help us prove evolution? There's 4 different things. If you look at lesson 10 from yesterday, good, Austin. Exactly, anatomy. The actual body parts of organisms that live today, we're going to compare them. What other things do they use? Dwayne? Exactly, the DNA, the proteins that our bodies make, our biochemistry, what we find in our blood. We have 90% of the same DNA as cats. We have 98.6 to 99% of the same DNA as chimpanzees and the bonobos monkey. We have 80% of the same DNA as cows. 60% of our DNA is shared with flies. 50% of our DNA is shared with bananas. Why do we share DNA? Because we all have the same common ancestor. So, all organisms are made up of what? What's the structure of organisms? We're made up of, you have to be living. In order to be made up of this, only things that are living are made up of these little microscopic units of structure. Thank you, Darian. We're all made up of cells. So to make a cell, they have the same parts. Everybody has the same parts. Can you show the light, Amanda? All right. So scientists use fossils, anatomy, biochemistry. They compare all these things, and they also compare one more thing. What's the last thing that scientists compare? The last thing that we compare, Austin. Embryology. What is embryology again, Ash? What is embryology? Yeah, how organisms develop. What they look like when they develop. So when you look at an embryo of a chicken and a human, do they look different? They actually look almost the same. They're very, very similar. So we mutated along the way, but there was a lot of mutations to differentiate us and chickens. Not as many as you think, though, because we share a lot of the same DNA. Today we're going to be looking at 3 different things. So before we get there, does anybody have any questions about last night's homework? It was pretty comprehensive. It talked about the father of evolution, the person that was the impetus for all of these theories. What was his name? What was his name, Jels? Charles Darwin. Good. So we have these important names that we need to recognize. Gregor Mendel for genetics, Charles Darwin for evolution. All these people made an impact, a legacy. Are you going to make a legacy? Are you going to do something in this world that is going to make an impact? It might not be in science. It could be in the music industry. It could be in the art industry. It could be in the business industry. Could be in fashion. Find your genius wherever it is. We all have our geniuses. All right, so let's look at our lab. So our lab looks like this. Everybody put your name on it. It's due on Tuesday. Tuesday's date is December. Is it the 12th? Well, today is the 8th. Saturday's the 9th. Sunday's the 10th. Monday's the 11th. It's due on the 12th. So December 12th we're due. This lab, due December 12th. Most of you will finish it in class if you're focused. If you choose not to be focused, then it's going to take you a longer amount of time. So discipline is the key to success. How disciplined are you? All right, who wants to read to us the background information? Go ahead, Asif. Thank you. So let's underline the evidence for evolution right now. We just talked about this a couple of minutes ago. So the evidence for evolution I'm going to highlight. Somebody raise your hand and let's reiterate them. The 4 pieces of evidence are, first one is what, Elizabeth? Thank you. Good. The second one is what, Peyton? Embryology. You're right. Sean, give me the third one. Thank you. And Michael, give me the last one. What's the last piece of evidence? Yes, comparative anatomy. We're going to focus on this, comparative anatomy. So in this lab, you're going to learn about the homologous, analogous, and the vestigial structures and how they're significant in evolutionary theory. So we are going to be using colored pencils and worksheets. We're going to be defining these terms first, and then you're going to be analyzing their functions. Then you're going to be looking at other things. So let's look at the next page. I'm giving you an example. I chose the color purple. You could choose any color you want. On the side, I made a little key. So this is the humerus bone. You have to find that bone in all of the organisms and then color it in. So on the cat, it's up here. It's not that difficult. But don't change the color. If you choose the color purple for the humerus, all of them have to be purple. So I'm using the crayon function. When you do the radius, you pick the same color. Not purple, though. Pick a new color. Maybe the radius you're going to color red. Who knows? So you're going to compare each of the bones for each one and make a tiny little key. You're going to answer the questions. They're not that difficult. How do we find the definitions? Well, you guys are smart enough to infer, but there is a place to find them easily. Not your textbook. There's another reference that you have. What is your reference, Trevor, that we could find the definitions very easily? The evolution packet. So go to the first page, please. All of the terms on your evolution packet are in alphabetical order. So it would be nice if you guys highlighted those now so that you can find them easily. Jaden, on page 1 of your evolution packet, you could use a pencil, a crayon, whatever. You can put a little star next to them. You can highlight them. You can circle the words, highlight them. Just the 3 terms we're looking at. So right now, let's look at the first term. The first term we're going to look at is, no, homologous structures. Look for the word homologous structures. It's alphabetical order. It's actually right where your hole punch is. You found it? So I'm going to highlight it on the board, part 1. Let's define it together. Who would like to give me a definition of a homologous structure? Go ahead, Dwayne. Thank you. So we're going to write that down. I'm going to abbreviate it in my own words so that I understand it. Because when you write textbook definitions, are they easy for you to understand? Now, you want to reword it so that you can understand it so you're not memorizing, you're understanding. Homologous structures, look at the word or the prefix, the piece of this. Yeah, homo. We learn homozygous. What does that mean? Homozygous, Austin? It means the same. So these organisms have the same body parts. So it's parts that look alike, that are the same, but there's a factor that makes them different. These are the parts that are the same. Parts that are the same, but have different what? Different functions or different jobs. Parts that are the same, but have different jobs. So you're going to be looking at these and comparing them. Let's go to part 2. What's the term that we are going to be looking for in our packet? Part 2, highlight it. What's the second term, Kaylee? Part 2, what's the second term? Yes, you say that better than I do. Analogous. I think I'm getting better at it. Analogous structures. I could say it and then I mess it up the next time. Who can read to me the definition for analogous structures? Tyler, find it on the first page and read it. Good. So this is actually the opposite. Oh, do we see the A in the beginning? The prefix? That means against or opposite. Notice how words are written for a meaning. So these body parts have the same function, but they have a different structure. The same job, but different. Same job, but different structure. That means they look different. They look differently. Adverb. Okay, let's look at the next one, part 3. These. Yes, my love. Part 3. Oh, part 3 is down here, so I don't have to even go anywhere. Part 3 is called what, Asif? What structures are we looking at here? Well, that's for the analogous structures. How about in part 3? Yes, the vestigial structures. We learned that word yesterday with the ears, right? Our muscles in our ears. I can't do it, but some of you still have the ability to move your ears. Still? What does that mean? That at one point, moving our ears was something that we needed to survive. We don't use that anymore. We talked about the ears. I don't know if I talked about it in this class, but I talked about it in a different class. Lions. Lions live in prides. They don't eat every single day, so they have to conserve their energy. So if they hear prey, or if their pack leader has to give a message, they got to find that information quickly. So they have the ability to rotate their ears in the direction of the sound. They physically move the muscles in their ears to look in that direction. They don't move their heads, they just move their ears. And they localize the sound that way. Other organisms have the ability to move their ears as well for different survival reasons. We had that ability at one point to move our ears, but we don't have that ability anymore because we don't need it. It's not something that we need to survive. So what do you think a vestigial structure is? Somebody go to the first page and tell me. Vestigial structure. What does it say, James? Yes. The body part that lost its original function in evolution. Through evolution. Humans have over 100 vestigial structures. 100. Those things used to do something for us, but they no longer have that function. I just think that's fascinating. Because I'm wondering what else we'll lose that lost its original function through evolution. And we know that this has taken us millions of years to lose those functions. The original organism that resembled a human was over 3 million years ago. The civilized humans are only about 13,000 years in existence. But our evolutionary tree that we can trace back to fossils is about 3 million years ago. First fossil found in Africa. So all of these things, the history of us is amazing to me. All right, so the last section gives you an example of a catfish and a minnow, and I want to show you the actual physical piece because I feel like the picture on your lab is a little bit nebulous. This is a minnow, and that is a cave fish. So I'll keep this picture up here if you want to look at it with the lab. You're allowed to work with a partner, or you can work by yourself. I'm giving you the opportunity to choose your partner because survival of the fittest. If you are disciplined, you'll be successful. So you decide who is going to get the best grades in here, the person that works the hardest. This is a very, very, very good lab because everybody can get 100 on it. Okay. You have the rest of the period to work on it.